Okay, in the last video we talked about the basic parts. So we're going to go with that we know what the initial side is and things like that. Now we're going to talk about something that is called a radian. And a radian is sometimes a misunderstood entity with trigonometry. So hopefully we're going to look at what a radian is and we get a good understanding of what a radian is. So we're going to talk about a radian. Okay, a radian. So, what is a radian? Well, let's start out with a circle. And I always wonder what to do with these old CDs. So, I usually have them around and I use them here and there. So, I'm going to go ahead and mark what I think is pretty darn close to the center. And I'm going to use this nice old CD cover. It was actually the top CD of my stack. And I'm going to make a circle. So, I've got a circle and then I have the center. Okay, now and the screen, that doesn't look exactly like the center, but it's pretty darn, it is pretty darn close. Okay, so what is a radian? Well, let's start out by drawing a ray, or really in this case, we're just going to do a simple segment here to represent part of a ray that would be at the standard position in a circle. And I want to first define something that we call a central angle first. It's important that we know what a central angle is. So what is a central angle? A central angle is two radii that are in a circle that form an angle. That's pretty simple. Just take two radii in a circle and they form an angle. So let's make an angle. And this is my favorite part because I think that looks like a little Pac-Man. Okay, and I think the old Pac-Man game was, well, jump, 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 jump. So I call that a Pac-Man angle. Jump, 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 jump. So the central angle is an angle formed, okay? An angle formed and from the center of a circle, and we're finding that the vertex is the center. So let's put C for center here. Okay, got it? So I call that a Pac-Man angle. But Pac-Man angles, I've never found a math book that has the word Pac-Man angle in it. So when I say draw a Pac-Man angle of 60 degrees, what I want you to do is to draw a central angle 60 degrees. Now, I'm never going to really want to call it a Pac-Man angle. You need to know it's called a central angle. But if you want to know what I think it looks like a Pac-Man. So this little Pac-Man is going to go eat up other things, like right over here. It's going to see this thing over here, and it's going to go jump, 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 jump. Okay, so enough of that. So let's go ahead and talk about the radian a little more. So what is a radian? Well, let's see. Let's do that. Let's do this again. Let's put our circle here. Here's the center. Let's get used to doing this. You could use anything for this for your homework. You could use quarters. You could use half dollars. I think nickels the smallest you want to go with for your drawings. But don't use no dimes, no pennies. But have yourself a quarter for class all the time, and everybody will be happy. So what is a radian? Well, here's what a radian is. Okay, so we're going to start out with one of the radius of the circle at what looks like a central angle. And what I'm going to do is I'm going to take, and I've got some wire here. Okay, grab some wire from the garage, and I'm going to mark what the length of one radius is on this wire. Okay, so I'm going to put that right there. You notice I put it right there, and I'm measuring for this circle the length of the radius. Okay, so there's the length of the radius. So I'm going to take my handy dandy wire clippers. Okay, handy dandy wire clippers. These things have been around for a long time. And if you notice really carefully there, I'm cutting right on the mark and go clip. Okay, oh, that thing flew away. Okay, so what do we have here now? We have a radius. Okay, now I could take this radius anywhere for this circle, and let's just check it. Does it look to be the right? Yes, it is. Look at that thing. It's like perfect. It's right the exact length of the radius. So now what is a radian? Well, a radian is, first of all, when you're saying, well, why did I get this piece of wire, which is the length of a radius, when I want to make a radian? So let's put down, what is a radian? A radian is an angle measure. It's an angle measure. Remember, if anybody on the street asks you, what is a radian? The first things I want you to say, a radian is an angle measure, okay? It's an angle measure. Okay, don't say anything else other than that. Okay, a radian is an angle measure. Okay, don't say it's something else, but just get that through. Hello, what is a radian? A radian is an angle measure. Okay, you got it. That's the first start. Well, what do you mean it's an angle measure? Well, how does this straight line right here that I have right here is going to be an angle measure? It doesn't look like an angle measure. No, because now we have to have a word that is like subtend. We got another word, subtend. Subtend. What's subtend mean? Well, let's go back. Let's go back. What does subtend mean? Let's go back to our Pac-Man angle. This angle here subtends this arc. Okay, so let's label it. Label this A, label this B. Okay, so arc AB is subtended by angle BCA. Okay, it's kind of like it chops it out, that part of the circle. So this angle subtends this arc. It means like it chops out. Pretend it's a Pac-Man. What did the Pac-Man do? It subtended that arc. Okay, it like ate that arc. So that arc is the one that's subtended. So let's go back to what we're talking about, radians. So you got to know about subtend, because a radian is an angle measure that subtends an arc. It subtends an arc. Okay, so a radian is an angle measure, okay, in a circle. Okay, is an angle measure in a circle where that central angle, okay, subtends an arc. Okay, now let's get that straight. A radian is an angle measure in a circle where that central angle subtends an arc whose length, okay, is exactly, not a little bit, not a close, not a what, exactly the length, okay, of the radius. So how are we going to show that? What do I have here? I've got a wire that is the length of the radius, but why did I grab a wire? Because wires can bend. So here's what I'm going to do. I'm going to see what that is, what that angle is. So we have to take this and we have to bend this. Okay, now I'm going to bend this, and I'm going to use my trusty CD here thing to bend this thing around here, okay, a little bit. And there it is. See how it's sitting there right along the edge? Okay, got it? Okay, it's sitting right there. Okay, so what I'm going to do is I'm going to take this thing and I'm going to keep moving it around. So what I'm going to do is here, I'm going to put here for start. Okay, start. And what I'm going to do is I'm going to mark this thing. I'm going to put it here, one. So one of this is one radius. Okay, and here is, if you see what I'm doing it now. Here is where the second one is, okay. There's number 2. Got it? There's number 2. And let's see. We're going to see how many of these go around the circle. Maybe some of you have guessed it already. Maybe some of you have seen this before. Many of you are probably just going to be thrilled and happy that you're learning all this good stuff about what makes up a radian. You probably never knew what a radian was, or maybe you did. You thought you did. People on the street, they say, "Oh, I know some people from Mr. Huss's class that they're going to know what a radian is because they've seen this great YouTube, right?" Okay, so let's put this one more. Okay, one more. We got number 5 here. Number 5. Okay, and now number 6. Wait a second. We didn't make it to the start, did we? Okay, we'll figure that out in a second. Okay, so we haven't made it back to the start, and there's 6 of them, okay? So let's go ahead, and we've got our straight edge here, and let's figure out what this is. Okay, so this Pac-Man angle, otherwise known as a central angle in proper terminology, this is the measure 1. And you say, wait, 1. How did I put 1 there? And I didn't put any degree mark. Well, it's not a degree, so I don't use a degree mark. It's a radian. So somebody will say, well, wait a second. How many degrees would it be? Because we've been working all our lives in degree land. Let's see what we think it might be close to. Okay, I'm going to put my protractor here, and I look at it, and it measures looks like it's about 57 degrees, pretty close. It's about, so this one, whatever that one is that's 1 radian. So I like to put rad here. I like to put rad because sometimes we forget what this number is. So I'll put rad, and actually that doesn't have any dimensions to it at all. It doesn't have a degree or anything. So 1 rad is about 57 degrees. Well, okay, so how can we figure that out? Well, let's figure out, what do we know? If I just decided, for the heck of it, to say, well, what if I gave the length of this radius here, what if I said that was 1 unit? Okay, I said it was 1 unit. Then what would I know about? I would know about, well, I know that how many units go around the circle. Well, going around a circle, isn't that the perimeter of a circle? What do we call that? We call that the circumference. Okay, so the circumference of the circle, C is equal to 2 pi r, okay, or is equal to pi d, either one. Okay, so we know that, well, let's see, we came up short 6. Why did we come up short 6? Well, let's see, what if we had 1 unit, that's what we did here, one piece of wire was 1 unit, and 2 pi r, so what is C? C is equal to 2 pi times 1, okay, because it's 1 unit long, that radius, and so that meant this was 2 pi. Well, that's pretty difficult to talk about pi here because pi is a number, and we don't know what the number is because it just kind of goes on and on, but we know it's about 3.14159. Let's just use 3.14. So we can take 3.14 on the side, 314 times 2, and we get 6.28. So the circumference of this circle, this one, C is equal to 6.28 units. So therefore, that's why we ran short. We only put 6 units there. Well, what do we know? We know that there is 6.28 units per what? 6.2 units per 360 degrees, correct? Correct? Would we agree there? And so now what would we say? How many units? We have 1 unit now. Remember, 1 unit is going to be to how many degrees? So 1 unit would be to how many degrees? Okay, and that would be that 1 unit. Now that would be the degrees, right? This would be degrees, and this 1 unit relates to the length of 1 radius, because that's what that was. So let's solve for that. Let's figure out what that degree is. And let's just go ahead and leave it as question mark. So I'm going to put it back here, 6.28, okay, is to then 360 degrees is equal to 1 divided by question mark. So what do we have? Question mark times 6.28. Now that really is 2 pi. So maybe we'll use our calculator and we will go ahead and use 2 pi instead of approximating. So that's equal to 360 degrees. So the question mark is going to be now 360 divided by 2 pi. So let's put that now in a calculator, and let's see if I can get this calculator to work. I don't know. I've got this one sitting around here, so I'm going to put, let's see, what am I supposed to do? 360 divided by 2 pi. So I'm going to put 360 divided by 2 times pi. And there's my pi button. And if I look real closely, it says 57.2958. So this is 57.22958. And that's the 4 decimals, and that's degrees. So now we know 1 radian, okay, is equal to 57, roughly. It's not equal to it. It's approximately equal to that there. So now let's go ahead and fill in one other thing. So what we really know, here's simply stated. Since we know if we kind of dashed our line across here, and we're almost going to be out here. If we dashed our line here, this is going to be 3.14 or pi across. And so therefore we know we have 180 degrees is equal to pi radians, okay? So pi radians. And we're going to use that identity for all our problems. And what we're going to do is we're going to pick it up on the next video, and we're going to talk about the unit circle, and we're going to make a unit circle, and we'll do that then.